这档就是没有很完，
因为 NPeg 本身太复杂了，所以一定不可能改到所有的。
对，而且 NPeg 它还是你把东西投给他，然后他会把 data 输在他版本，然后他另外一个设的话是然后再扣回来。所以刚刚那一整条路就是之前都走到，就是遇到这些奇怪的情况。所以你有在用 C 吗？
有。
我刚好听你聊到就是你们 code 考到的问题。
code 考到也还好，因为我主要会用 C 构的部分是 Windows 的部分，然后并且那个专门就是都没什么问题。
哦，然后你应该 Windows 上做。
应该说我会用到 C 构的地方是在要 compare Windows 上的时候。就是 static link 的变换多，我觉得又比蛮多。
我记得就是 Windows 上你要用 C 构的话，你要先把命去打开，那个句子把它装好。
但我 compile 的时候一定会电脑上下。
哦，现在你有 close compile 的。
其实还算蛮简单的。但也是归功于我用的那个 library 本身没有太多奇怪的功能。
那就对了，那好的，
就它搞到我全完全不一样。
我是2点半。对对对，我觉得你的酷，就是用开发一个设计系统，就蛮屌的。那主持人呢？也是一个音乐团。所以最后变成一个 OS。那这样你们，它是一个完整 OS 吗？还是只是做它桌面系统的一个皮？所以等于是你决定也是接下来出一个。那现在有其他的桌面系统，就是网页的桌面系统，就是其他的开源专门拿来做的事情。哦，我知道这个事。可是我有问他这个，他是在抓形上把这段的东西。所以群晖做的，对他们家自己的 OS 其实就是这种类似这样的概念。所以有人用这一套，然后去把群晖在他大致上。出 NAS， 但是开源在 NAS。专案的。所以这是你们的 OS 点。吉祥物。那个口耳哦。
哦，你要英文讲？
对，这个 section 是英文讲的。
这是有英文讲的。
对，要提醒一下。
好，差不多。OK， 好，那就是很高兴我们回来，就是我们今天勾认社群轨的应该是最后一个 talk。对，然后是有，我觉得这题目非常的酷，就一般就是勾认可能就会拿来开发 web service 最大众嘛。那今天这个题目就是用Go来开发一个网页桌面系统，就是我当时看到题目就觉得啊，这真的是太屌了，就一定要让 Toby 来讲一下这个题目。好，然后所以如果等一下 Toby 带来的这个 session 会用英文进行的，对，然后所以就是就是先跟大家讲一下。好，那我们就掌声欢迎 Toby。
好 ，testing 好，对，那个今天这个 session 呢会用英文讲的，所以如果有什么问题的时候，可以在后面 Q&A 问，那 Q&A 英文、中文都可以。这样好。So today I'm going to introduce my topic today, which is called RSOS, building a web desktop system from the ground up with Go. So if I have to summarize today's talk in one sentence, it would be something like, I accidentally created a web desktop system and it turns out to be really great. So before I start this sharing session, I want to ask a simple question. Has anyone used a web desktop system before? You can raise up your hand if you have ever used one. All right, one. Any more? Like, you have heard of what is a web desktop system? Anyone? Okay, no. All right. Okay. For those who never heard of or don't know what is a web desktop system, a web desktop or webtop is a desktop environment embedded in a web browser or similar client applications. So in simple words, you are using your desktop environment inside your browser, like Firefox, Safari, for example. And before RSOS actually released as an open source project, there are already a few of this kind of open source desktop projects on the market, on the internet. One of the most famous one is the os.js, which is a JavaScript-based web desktop environment. And there are also different kind of native desktop clone websites. For example, this is an example of the Windows 98.js, which is a CSS and HTML5 clone of the Windows 98, of course. But for RSOS, it's most likely categorized in the web desktop-like management interface. So this is an example of the NAS management interface from Synology DSM. And I'll talk about how it's similar with the RSOS later sections. So what is RSOS? RSOS stands for Ars Online System, which is an open source web desktop system developed by me and a few authors since late 2016. This project originally written in PHP, and due to some technical reasons, we migrate to Golang later. And the project is currently under open source under GPL v3. So in this 3-second videos, I will show you what our user actually use RSOS for. So of course, RSOS is a web desktop environment, so you can do basically any kind of file operations on it. Some people do use it as a self-host cloud storage system for storing the files, or as a Google Drive alternatives. And but it is mostly used as a music and video streaming system. So basically, you stream video from your own server or your own systems. Okay. Alright. Before I go into the technical details, I want to introduce our authors and our users. So I'm Toby Choi. I'm currently a master student in NCKU. I previously graduated from the Hong Kong Polytechnic Universities, and I'm the main author and the project owner of this project. So basically, anything that is not written by our co-authors are written by me. And on the right-hand side, this is Alan Young. He's a US student studying CE, I remember. He handles anything related to security features of the system, including OAuth, LDAP, IP blacklist, etc. He's also our QA engineer that always breaks our nightly builds, so we call him the software destroyer. This project is used by a few of the edtech companies and VFX Studio and other organizations I'm going to list here. So our OS system doesn't actually start as a web desktop system. It actually starts as a music player. So back in 2015 and 2016, when I'm still a high school student, I developed myself a music archiving and storage system. So basically, it referenced another program called Sakura Script Player, and I added a music player to it so it can play music. And later on, I brought my search server, so I migrated from, I remember, VB.NET to PHP and make it the RS Online system where it can now stream video and music to my phone via the internet. And a few years later, I entered universities. I add in more and more features into it, including authentications, more different kind of web apps to handle different kind of files types. I even add a file manager into it so that you can basically manage files across different web apps. However, I encountered into a problem where a dashboard-based system actually have in common, which is when you're trying to do multitasking, like doing a file operation, for example, it is much slower compared to a Windows-based system. One example is that you want to move one folder, one file from one subfolder to another subfolder. On Google Drive, you do right-click, select, and then move it multiple steps upward, and then select the file you want to put in it, and then move there. And on a Windows-based system, you just drag and drop across two windows. Simple, right? So that is why I made my first prototype of a web desktop environment. And it basically do two things. One is remember the file you put into it in the location on your desktop. And secondly is open other kind of web app in an iframe. And this system, I open source the system, and then many users came into using the system, and we improved it throughout a few years of time. And this is the version now. We have much better localization, much better design, and overall much better user experience. So in case you wonder how we actually use this system on mobile phone, we actually have a specialized interface for it called the RSOS Mobile, which is powered by PWA. So you can also do multitasking on your phone with these PWA applications. And of course, RSOS still got its original media player function in the latest build. And in this photo here, you can see that this is our music player, and on the right, this is our video player in the latest versions. So, the content of today's sharing. First of all, I will talk about how RSOS work. I will talk about why and how we migrate from PHP to Golang. What we actually think of when we are choosing a new architecture for developing this system, how we actually enable user scripting in Golang using a JavaScript interpreters, how we design hot pluggable modules for Go, and if we got enough time, I will talk about OTA updates in Golang. All right, no problem. Okay, let's start. How it works. Many people see this project and think it might be some kind of web VNC or some kind of remote desktop thing, but actually no. The RSOS is more like a virtualized OS on top of a real operating system. So on the bottom here, we have the Debian or Windows. Mostly we recommend our user to use this. And this operating system provides packages or APIs for us to work on. For example, like core utils, IP root for networking stuff on Linux, and WinFree.dll and .mic on Windows. So in the RSOS core, we developed the real file system and the hardware adapters for this kind of packages in the host operating system. And we use these adapters to provide something called a virtual file system and a virtual hardware abstraction layers that further can be used by our gateway interface, something similar to serverless scripting, I will talk about in later sections, and a RESTful API that can be used by web apps and subservers, and finally integrated into a web desktop interface. So this is the overall infrastructure of the RSOS system. So because due to time limitation, I'm going to go into detail about how these things work. But in simple words, the virtual file system was originally developed to protect the host OS from something like path escape or some script injections. But it also has a side effect of bringing an easy web app development. So we currently separate the vpath translator into three parts. So we have a real file system abstraction object, or the real object. What a path is translated direct to a file on a physical disk on the host operating system. We have a virtual object that handles things that don't translate to a real file system, but some kind of tree data structure or representation of a file in the host operating system. And finally, a backup abstraction object which handle something similar to RAID and snapshot, but not exactly splitting the files in the disk. So this is how we actually access it in the web app programming. So we have a virtual path you see here, which doesn't actually exist in the host operating system, but we translate it to another path that exists on the host operating system to do further processing. So another features of the RSOS system is called the hardware abstraction layers. So we have a set of APIs that provide the same data structure across different kind of OS for making hardware specific conditions to be optimizable by our code. So for example, we have something called low memory upload mode for specific design for running on Raspberry Pi 0W with 500 megabyte of RAM. And this is achievable by something called conditional compilations. So basically, we have different kind of adapters for different kind of operating system on our operating system. So if you wonder how we actually do it, we do it like this with some shell magic. And for Windows, it's a mess. So I'm going to skip this part. So how we actually migrate from PHP to Go, and why we actually need to do that? PHP is a good language, right? It's suitable for rapid development. It is easy to code. You don't need compilations. And at the time I'm actually developing this project, many other NAS OS like OpenMediaVault or Nextcloud do use PHP for their front end. However, when we're actually trying to use this for moving some large file, for example, when we try to create a virtual machine manager on top of it, and we start to get some problems. When PHP actually do this kind of heavy lifting things, it will stuck the Apache because of the fast CGI design, and we can't actually have a way to let the user know if the server has crashed or it's just freezed. And a few of the users at the time also complained to us about this issue, and we need to serve out an update zip file for them to actually patch the system. So we can't use anything with dependencies like Node.js or Python. We also can't change the runtime environment, of course. So what we can do is something pre-compiled, run very fast, and easy to use. We thought about C and C++, but later on we chose Go because it has a really cute mascot, as well as they have something called a PHP to Go module. Basically, our developers originally are PHP developers, right? They don't really know how to write Golang. So we've discovered this module and then allowed them for easy translation of their PHP script into Golang. So this is how I lead my team to start migrating from PHP to Go. And basically, at that time, everyone of us only know PHP, and now we started transition to Golang at the time. And this is how we fix it temporarily. So instead of PHP directly moving the files, we have a PHP calling to the kernel, the Linux kernel or the user space, and then it will start a Go program where the Go program will do the heavy lifting thing like file operations, for example, and using a Go routine to write the file progress into a log file where the client can read. So our client can know that the server is not freezed and the server is responding to new requests. So, but why we eventually migrate the whole system to Go, you ask? Well, because once we release this update, what we call the fsexec for handling file operations, and more users ask for faster operation on different kind of perspective of the system, like fsconvert for handling UTF-8 conversion. Back then, PHP 5 and PHP 7 doesn't actually handle Unicode that well. They also request fszip for handling large file zipping, like when you download from Google, they will automatically zip files, right? And it to a point that the PHP project contained too many Go programs. So we decided, okay, screw it. We just remove the PHP part and then rewrite the whole system in Golang. So this is why we actually migrate to a new language. And with new language, we can pick a new architecture to work with. So what is the correct architecture to work with? Well, at the time, we think that SOA is the best option because according to our usage, we think that SOA might be the future. And we also consider about microservices, but back then, we are just university students. We don't know how to write microservices, and eventually it will become a distributed monolith, which is even more difficult to maintain. So we designed it based on some extreme use case we received in our previous development. So in our previous development, when we are working on the RS Online beta system, we do receive a few emails asking for a really specific use case. One of the most memorizable one is that a teacher from I don't know where, maybe Africa, maybe, that he want to set up a NAS system for their student in a remote part of the village that doesn't have internet. And he sent us an email for asking how do we set up the RS Online Beta in an environment with completely no internet. And we, based on his request, we actually spent a few months to add complete offline support into our beta version, including removing any CDN and etc. So in the new architecture, we decided to stick with these two special requirements. First of all, the system has to run with no network environment, and secondly, it can be run as a portable app. So basically, you can put your complete desktop environment in a USB drive and then put it everywhere. So single executable is the best option here. And we also add a few rules for developing the new system, including no external runtime dependencies. Like if your module requires FFmpeg to run and the system doesn't have FFmpeg, the system cannot cause the core to crash. And no runtime online dependencies, including no CDN and no external APIs. And we also classify it into 3 categories: core, web apps, and subservices, where the web apps are applications that requires mostly front-end calculation, HTML5 web app, for example, with little to no back-end access. And subservices are for those that cannot be fit into the first 2 categories. We'll go into subservices. And this is the project structure, which is a really standard Golang project structure. We do use mod instead of PKG because, well, we like it. And with a bunch of Go code of the highest abstraction layers of the whole project. If you want to take a look at the source code, you can scan the QR code right here. But later on in the Q&A section, I will give you guys these cute cards where you can have your QR code on the cards as well. So web app and backend. How we actually migrate the PHP script into a new system. So I think most of you have written PHP sometime before, right? So in simple words, PHP is an event-based language. So it doesn't actually run in a loop like Python, Node.js, or Go do. They only execute when you request it. So we need to replace the PHP part and make it Golang part. So we also have 2 requirements for this. One is hot pluggable. We don't want to recompile our system every time we install a new web apps. And we also want it to be migrated with as little rewrite as possible. So replacing a single or limited number of PHP APIs is very simple. You just replace the .php with nothing, and then you rewrite your PHP script in a Golang HTTP handle functions. However, we have like 100 and few PHP scripts that need to be migrated, and there's no way for us to add an API for each of the PHP scripts to be replaced. There will be too many API endpoints, and we can't actually have anyone to maintain it. On the other hand, if we use a generic RESTful API for this, for example, like operation 1 for file operations, operation 2 for permission checking, then the front end need to be modified too much in order to compensate for the PHP migrations. So is there any way you can do to make it more similar to a serverless design? So this is why we actually use Auto. Auto is a JavaScript interpreter written in Go. Basically, we expose a virtual machine interface for the front end to execute a section of JavaScript code or a specific file of JavaScript into the Auto VM, and then the Auto VM will interchange data with the RSOS core, allow it to provide and calculate the required result for the front end applications. So after some evaluation and development, we call it the RS Gateway Interface, or AGI. There is a 100-page long technical white paper on our GitHub page. If you are interested, you can take a look at it. So in order to make our developer happier, so we develop a front-end wrapper library for it, and it can be easily be used like this. So you just call the Auto VM with a section of the path of the JavaScript file that you are referencing, and with the variable right here, and then it will just execute your stuff and then return the result to you. Simple. And you mentioned that we have a Go function adapters, right? And this is how we actually do the Go function adapters. So we actually allow the VM to escape and interrupt from a section of code when it's called to a virtual native JavaScript interface or functions. And in the Go code, it would do its Golang things and then return the result back into the functions. Okay. And this is how we have a whole set of web apps migrated from PHP to Golang. Now, the web apps can call the Go functions, of course, install, remove, reload, or during the RSOS is running. So subservice. I think this is a little bit more interesting part. Because subservice allowed not only Go developers, but even like Node.js developer, Python developer to develop RSOS with this interface. So first of all, I'll talk about hot plugin plugin for Golang. So currently there's no cross-platform and cross-architecture Golangish way to actually do a plugin in Golang. So there's a few open source projects or native packages that do it, but it either requires CGO or linker files that only limited executable to run on certain platforms, or it requires gRPCs, where it will add too much complexity on our web app development. So we can take a look on how other people do it. Most people use Docker and then expose a new port to a reverse proxy and open the path in an iframe or new windows. Or some projects like Sandstorm, I remember, do modify their original open source app to fit their system. So is there any better solution to that? So we just use reverse proxy. So reverse proxy is basically just an application that allows external incoming requests to be routed to a local server in your local area networks. But we don't actually use it this way. We use it to route local hosts with different port web applications to the same port where the RSOS is using. So for example, you can route an Apache with a PHP script into our front end as some kind of web applications. You can also reverse proxy some kind of binary executable with web UI, for example, like SyncThings, a famous file synchronized software, open source also. And with GoTTY support, which is another Go open source project, you can also reverse proxy a terminal application on the web UI. Something similar to a PuTTY or SSH connection will show up on the RSOS system. So my co-author actually used this method to host his Minecraft server on the RSOS system, so you can do it if you are interested. And the overall architecture of the RS on a subservice system will look like this. So I'm not going to go into detail from here, but if you're interested, our white paper is on our GitHub repo, so you can take a look on it. So implementing the reverse proxy. The reverse proxy actually is not difficult to implement. We have two originally built packages for this. One is the WebSocket proxy, another one is the reverse proxy from two open source developers. However, we need specific modification in that package to make it happen for two-way communication between our core program and a subservice. So how we actually do it? Well, first of all, we start the subservice using the execute command, which is nothing special around here, and then we execute in a Go routine, and we create a subservice proxy object that handles the reverse proxy, and lastly, we append it to the module list so that the users on the front end can actually see these modules. So, the question is, when we implement it in this way, there is no way for the subservice module to know what users are actually accessing these resources and how we actually interact with the Go core program. For example, like checking if he has certain permission or checking if the file actually exists or not. So we specifically added a RESTful API into it, so that every time a reverse proxy module is reverse proxying a request to your modules, your module can use that token with a section of JavaScript code or through our wrappers to access resources in the RSOS core. In this way, we establish two-way communication between the RSOS, which is the host operating system, and your modules, where it serves as a web app in our system. So if you don't like wrappers, of course, you can directly inject JavaScript in your Go program, but please don't do it because it's messy. You can't actually maintain this, and it's really ugly. Okay. And side note, we actually need a way for the RSOS to know how to launch your app. For example, if your app can be rescaled, it is suitable for PWA mode or running on phone or mobile devices. So we need something metadata to need to pass metadata from your apps to the RSOS core. And there are two ways to do it. One is use the wrapper, and another one is use a file-based flag, which is a hacky method to make it works. So the correct way, the official way to use it is passing a struct that allow the RSOS system to know how to actually launch your module. For example, this is a docx viewer from one of our co-authors. And you can also do it with a JSON file with your, for example, a Python server or your Node.js project that next to your start script where it can load and know how to actually launch your module in our system. So to summarize, there are 3 main types of apps in our OS system. One is web apps, one is subservice, one is core module. From the front-end developer perspective of view, it looks basically identical. The API is the same. The core procedure for the back-end data is identical. And from back-end, it is slightly different and designed for 3 different purposes. So, all right, we still got some time left, so we talk about OTA updates. Anyone know any official way to do OTA updates in Go? All right, no. Okay, this is also what I found on the internet. Basically, there's not much an OTA update method for Go programs. So before RS 1.120, remember, many users email us to ask how to update their RSOS system. And at that time, we don't actually have an official way to update it. So we tell them, first of all, you go into SSH, and then you log into your server, and then run that update.sh script. Do you see that script? It's right there. And then you tell him many times, many users ask this question. So we just write a launcher, okay? So this is why we developed our RSOS launcher. Basically what it does is that instead of letting the system D to start the RSOS system, we let our launcher to do the job, and the launcher is started by system D instead. So the process basically runs like this. So the RSOS system, when an update request is done, it will start downloading the files in an update folder where it will terminate itself with a specific, remember os.exist0, to allow the launcher to know that it exists correctly. And then the launcher will first of all back up the current system and then override the current system with the update folder's content. And the launcher also builds integrity check and result unpanic and automate rollback. So basically, these features you will usually find on a modern launcher. And we also designed this to be updatable via a simple JSON script. So if you are an OEM manufacturer or you're using this project in your company, you can easily change the vendor of the update source. So basically, if you have your own version of RSOS, you can change the link in a file so that your system, your company or system servers can be updated from your own repository instead. And if you're a Go developer as well, and you are looking for an OTA solution, we got a free one over here. And if you're interested, you can get it, try it on your project. Basically, it does the same thing with the RSOS launcher, but it has additional configuration to allow you to configure to update your own binary instead. All right, future plans. So what are we going to do with the RSOS project in the future? So you see that our current system is only limited to 1 machine, right? We don't actually have the capability to run the system on multiple machines. And in the future, we are planning to work on a distributed file system in Go. So basically, what it means is that you will have multiple nodes of RSOS system on your local area network. And with a master node, you can access all your files in your storage pool within this system. And we are also working on an open source NAS design powered by ARM or RISC-V SBC. And on the right-hand side, you can see this is our really early functional prototype of a NAS system that it didn't catch on fire, which is nice. Later on, we might add RISC-V support, but we are still discussing this one, and we also want to add better Chinese localization. So basically, if you have interested in helping this project, you can come to me after this section, and we can chat about how we can work together and contribute to this project. So quick summary. So if you want to know more about the RSOS project, this is the link to it. It works on basically anything. You can host it on ARM or x86 CPU devices like Raspberry Pi, Orange Pi, or whatever Pi, or old PC. It works on Linux or Windows, so if you've got an old Windows PC lying around, you can use it. And you can also access it through your PC or touch devices. And it's simple to set up, and it is free to open source. So if you're interested, please go to this link above here. And if you're more a technical person that wants to know about the details, how we actually design and implement this system, we have an RSOS white paper or technical documentation on our GitHub repo. You can find it under the SRC folder. And it is really long, so if you're interested, you can take a look at it yourself. So contribution. So the main reason I'm in this sharing section is that I'm looking for contributors for this project. So if you know anything about front-end developer or Go development, feel free to join our Telegram group. But Telegram group is more for support, technical support if you are using the system. And if you are developers, you can directly PR to our GitHub repo instead. So, okay. So this is basically the end of sharing. I got a few souvenirs here. If you are interested, you can come to me and I will give you some little cute cards right here. And if you have any questions, feel free to ask me as well. You can ask in Chinese or English, although my Chinese a little bit sucks. So, yeah. So, thanks for listening and have a nice day.哦，有，我们在那个我们的 GitHub repo 上面有一系列的 template。对，如果你是用 Go 语言写的，或者是用 Python 写的，或者是你只是纯粹的 HTML5 前端的 APP 都有 template。对，嘿，请说。
问一下，就是用你们这个 OS 上面，如果想要拿来做开发东西的话，他们能够支援什么？
资源你是指浏览器吗？
不是，我的意思是说，用我这个 OS， 然后比如说我想要开发 Go、开发 Java、开发 Python， 那我有很多资源。
哦，都有啊。我们在上面有一个 VS Code 的 clone 的样子的东西。对，你就可以直接在上面用 VS Code 的。嘿，请说。没错。啊，这个是一个很好的问题哦。其实蛮多用户也有问过这个问题，就是说我们可不可以加一个 web browser 在里面？但是问题是因为CLRS 的原则，我们没办法没错，这是这个问题。所以现在我们在开发的一个是直接把后端的一个浏览器的画面投影在上面这样。什么？对，我们这也在看这个部分，但是这个现在还没有计划在做。对。哎，请说。Terminal 环境吗？有 Terminal 环境，但是它并没有虚拟化，就是说我们有那个 Virtual File System 的 layer 嘛，那个虚拟环境是直接传取到后端的伺服器端的那个环境的，就没有直接可以传取到那个虚拟层的 Terminal 环境这样。对，是最后面的，对，这样子。
那现在它在上面还有什么其他的限制？比如说硬体的限制啊，像比如说 Webcam 啊，或者是
这个基本上我们都尽量去把资源加进去。我说装置好了，我们在做的 RISC-V 的板子也在研究怎么去 compile 在上面跑。现在支援的是 ARM x86、AMD64 跟基本上 Linux、Debian， 还有什么 FreeBSD 那边好像也可以。对。苹果的 M1 吗？有啊，能跑。
我刚刚问题其实是它能够 access 到哪些 host 的 power device？
这个其实它有那个 virtualized layer， 只可以让你传取到file system 的部分。如果你想要传取到 file system 以外的东西的话，你要透过 subsurface 来做。对，这是有一个特别的，因为那个是特别嘛，还有对硬体那边有特别的要求这样。所以我们是分类是把它放在 subsurface， 这样子的话，你的那个空间可以发挥的空间比较大。
那现在有哪些 subsurface 用来 access 这些特别？
我们之前有一个是用来做 CCTV 的感觉的东西，只是用 USB webcam 来做一个远端的 channel 的东西，对。但是这个后来没有人再开发了。对，我这里有一些小的纪念品，有兴趣可以过来拿一下。对，在走之前可以过来拿一下，这样。好。
好，那。
如果大家没有问题的话，就是很高兴今天 Toby 带来一个这么有趣的最后的一个 talk。然后今天这是我们一场馆的最后一场，那也谢谢大家今天的参与，那我们明年见，谢谢大家。
那我想问一下，
这样还有一些有没有
如果想要做一些很特殊的限制的话，比如说能够从外头传进去，然后可是不能从那个 browser 里这个 web desktop 传出来的话，有办法做到？就是
从里面主动传出来。
操作者 user 可以从外头把东西 copy 进去，可是不能从里头 copy 出来。
可以啊，我们有 WebDAV 跟 FTP 接口。
哦，你是说可以做这种限制？
可以看看好了，现在这个
可以。
因为没有时间关系，大多也是了，是现在的这样。可以做到，基本上都跟普通的 Windows 这样子用法的概念。可以拿几张？这一台是架在成大里面的一台 Orange Pi， 现在就是这样子。然后这是跑 ARM 处理器的。
不好意思，我意思是当初设计 OTA 的时候，没有考虑到用 container 的方式去设计。
Container 是一个我们不想去的方向。
我不想去的方向。
对，因为这是那个我们刚才讲嘛，是尽量避免外面第三方的一些 dependency 来做。
因为这样要假如写这样的话，那就算要加 container，可以让使用者直接自己去替换。
没错。
系统里面所有的 UI 都是用 Web 里面的元件试做的。
对，这是原生的。
有没有就是像有些，我看之前看到有些试做是用做一个 X1的那个 headless 的 server， 让应用程式就是假如说跑一个 container， 然后它去接到这个 X1的 server 上，然后它就可以在 Web 里面直接显示它的那个视窗。有没有这方面的试做？
没有，我们没有在做的。
可以直接开一个卷图在那个网页。
因为这样子没有办法做到 user isolation。其实这个系统其实那个最大的特点是它有那个 user isolation 的功能，它是这样子的，你可以很明显的分得出不同权限群组的做法。
像其他设计
想问一下，目前在起 server 的时候，可以直接下个费避免一些危险的操作，就是像刚才开 shell， 可以直接在起 server 的时候先起一个 flag， 先禁用这个。就是你刚不是说可以直接现在在里面开 shell？
可以啊。
那可以就是起 backend 的时候先下个 flag， 然后让它禁止使用者。
没有，那个是你要另外加进去的。
另外要再
对，你要再安装的。因为你是确定你的系统在一个安全的环境下才安装这个。
我也想要去，我也想去。
有兴趣可以直接过来按一下哦，反正这里面就没有。
我刚才按了。
应该没什么特别的吧？
不知道怎么，
不好意思，我想问，感觉像很明显，为什么会想要在你的作业系统里面再做一层当面性的转换？
因为之前那个我们的美国 co-offer 呢，他的伺服器经常被奇怪的人入城。
认啊，只有认。
然后我们都说那个他一开始是在试那个密码，就是后来就开始去扫他的
档案系统。
对，那就是用 PubScript 的东西去把他喜欢的档案插进去这样。所以我们就说，既然是这样子，我们就做一个虚拟存出来，你差怎么样也没差。
所以是给 host 的作业系统给一层保护，就对。
对，原本设计是保护，但是后来做其他开发者觉得，这样子很好用因为可以直接用它的。你看到这边啊，它这个 pub 其实并不是原本系统的那个 pub。
对，它是冒着进来。
对，所以 他们的 web 的开发者觉得，比起我要检测那是 Windows 还是 Linux 看那个 slash 方向怎样的，那直接用这个，那依赖我们后端的 translator 去把它转换成本地的，这更方便。对。
那它实际是怎么运用？是像Mount或者是
Mount 对，
它是Mount来做的。
看看这边，
就是用 share folder 的概念。
这里有一个我们要叫它的 storage pool 就是它是一个虚拟层的储存池的概念。就是说你可以把不同的资料夹从不同的是网络的地方，或者是从本地的地方放进来。
所以它可以放在网络上，比如说用
对，我们有一些
服务来放。
对，我听说有一些用户会把 NFS 放进去。
可是如果是 Mount 的权限的话，如果本地端那个权限不足的话，是就做不到。
对，它会自动跳成 read only。对。
那放进去之后，那个 file system 的 file 会做一层，可以做一层加密，就是让原本
它没有加密，这只是界面，它只是界面，对，它不会处理的部分。
好酷。
基本上我们有用户会在后面用 TrueNAS 或者是 FreeNAS 来做它后端 ，OMV 也有，但是我自己都裸跑了，都直接让它跑在那个 native 的系统上面。
应该没有用户跑在 NAS 上面。
好像有。
好像有。
我也知道。
我可以看一下你刚刚说的那个 APP 的页面，就是说可以有人有开发或者是上来的 APP 的页面。
你说 GitHub 的那个吗？
不是，是你说你们这边可以有一些就是可以下载来使用的 APP 之类，有点像是
App Store 的感觉。
懂对。
没有，它不是用 App Store 的，它是有2个方法去安装 App， 一个是直接用 Git 的 repository， 你把你直接跳进去就好了。另外一个是你是上传一个 zip 档案，让它去从那个 zip 档案里面把它安装。
未来会有人想要放 container 在里面跑？
这个是好问题哦。其实我们一直在找一个会 container、会 Docker 的人去把这种系统 Dockerize。其实很多用户也在问这个问题，但是我们这边没有喜欢用 Docker。对，我们这是用 VM 的。对，所以你可能会 Docker 吗？
我们公司就是这样子用的。
那你要兴趣快去留。
好。
要不然就直接对，你就直接先加这个Telegram 群组吧。然后对。
好。问一下我扫一下。
打项没那么多位置。
我可以帮你找场地。
场地没问题。
对。出讲者。
讲者啊。
那我们结束了，所以我们要好像偷录影出来确认这个录的确切。好。
就在这边问一下，有看到卡西吗？
卡西今天没有来。
没来，他还说。
Mocon 是有一个招募组啊，可是我们形式跟你们就比较不一样，因为 Mocon 比较算是 conference， 所以你们算是一个月。
我跟你讲，他办 conference 啊，不问我。
那就找啊，
因为我觉得要找一般的就是找志工可以找到，但是我看他们办出来之前，开始走到广州，你要先有一些东西，对，然后先 daily 对，才会走到。
我觉得语言类型的通常就是要会比较是属于那种比较凝聚力一点，对，比较 conference 的话可能就比较对，
因为他们就是世界级的，
它就是一个放烟火，对，放烟火的感觉。可是语言的话，感觉就是可能就是需要长期在一起。
没错，然后就是大家要熟啊，对，然后要。
而且像 conference 的，像我们 Mocon 这种的话，就是但是各个社群都可以来参加，或者是各个语言都可以来，对吧？比较不会，对，比较不会。虽然我是有被拉进有那个 colleague 的他们的 group 里面，他们说他们欢迎你愿意来玩就来，我而且 colleague 也可以来。然后他们现在常常办什么爬山、游泳啊。
是哦。
哇，他们每次聚会，他们每次说什么爬山、游泳、攀岩这样，然后去爬山、游泳、攀岩，然后一边讲 colleague 这样。
这是我们学
这是要听 building，
什么爬山、游泳啊，吃饭聚餐的。
没有听力啊，没有听力过的，但是要听 building。
对啊，因为如果你办那个什么 TED Talk， 可能不要就真的不会，就只会写够了来这样而已。
我那今天有预算，公共上有预算，可以看。
可能要请大家有那种最好亲子讨论可以带小朋友。
对吧？
好吧。
可以看看。我是被拉进去才知道说，啊，我不会写 content， 我都进来可以干嘛？他就说没有啊，
等于你嘎了很多这种社群。
对啊，也算是，可是我就没有到，像 Colin 那边就是他们说哦要玩桌游啊，走去。
哇。
对啊。对啊，那其实有时候就是边玩桌游就会刚好就会聊到就是技术面的东西，其实这样就不会那么的拘谨啊，比较轻松。
有给我一点启发，因为我对于新竹一般不太清楚，应该是要这样子。
新竹是
因为可以想说大家上班已经只是写够烦了，然后以出去玩的名义又来了。我可以，因为我已经有在你们 Telegram 那个让我觉得，或者是他们都 calling 要帮我们够要不要 cross 一下？cross 要 calling 可以帮忙写前端，我也可以写前端。
写 app， 座椅开起来。 在可以接受，但我觉得。